Okay, the last thing we want to do, we found the midpoint, we found the gradient of a line. Let's suppose we wanted to find the distance between this point, 2, 1, and this point, 6, 5. How would we go about finding the distance between these 2 points? And there's a little hint here already, and your task is to really just see if you could figure out a formula for it. But if we use the little hint up here, we've drawn our little triangle, which is always good because it's a right-angled triangle. Now, the vertical distance or the y distance is going to be 5 minus 1 is 4. And the horizontal distance is 6 minus 2. So what we've got is that this length here is 4, and this length here is 4 in our little triangle. So then we can just use Pythagoras. The square root of 4 squared plus 4 squared, 5.6. That's all finding the distance between 2 points is. If we change it about here, so I've changed this triangle, or I've changed the distance, but the triangle, it's always still going to be some right-angled triangle. We can always draw this right-angled triangle. What's this length? It's going to be 4 minus 1. This is y equals 4. This is y equals 1, so this length is 3. What's this length? Well, the x value is 9. This x value is 2. So this length is 7. So if we look at it, we know that this length, just as I said, was 3. This length was 7. So it's just going to be 3 squared plus 7 squared. And if you look at this, what's the distance AB? The square root of 3 squared plus 7 squared, 7.62. And it doesn't matter how we draw this triangle. We could draw it like this. Okay, I'll just move that maybe to here. Okay, this one down. So we've got our little triangle here. We've got a right angle triangle. We can always draw that. The difference in the x's is going to be 6 minus 2 is 4. So this length is 4. The difference in the y's again is 5 minus 1. So that length is 4. So if we look at Pythagoras, it's just going to be 4 squared plus 4 squared, then take the square root. So hopefully you're understanding the formula a little bit as well. I wonder what happens if we take a negative number. And we'll try to lock it onto something there. Would have been nice if it was locked on automatically, but we can't have everything. Wonder what happens if we take a negative number. Well, does it change anything really at all? The y value here, it goes from 5 to 1. So this is going to be 4. This goes from 6 to minus 4. So what distance is that? Here we did 5 minus 1 to give 4. Here we're going to do 6 minus 4 to give 10. So you just got to be a bit careful. It's going to be 5 minus 1 is 4. And if we use our little hints, here it is. 5 minus 1 is 4. And the other one, it's going to be 6 minus 4, which is 10. So again, it's just going to be, what's the distance? The square root of 10 squared plus 4 squared. So the square root of what? 116. The square root of 116. That's over here a bit. Okay. So as I said, it doesn't matter if we make them both negative. It just doesn't click on. So well, there you go. They're both negative now. So this distance is going to be 5 minus 3. So the y value minus the other y value is 8. This is 6 minus 3, so it's going to be 9. We can use our little hint. This is 8 and 9, so it's the square root of 8 squared plus 9 squared. What's that? 81 plus 64, so it's going to be about 150. So it's the square root of 8 squared plus 9 squared, 12.4. And if we look at the formula, we might just move it up here. So the formula is a bit nicer. Here's the formula. It's the difference of the x's squared plus the difference of the y's squared. And again, the order doesn't really matter. You can do x1 minus x2, because the negative squared is just the positive squared. So hopefully that will help you do a few questions on the distance between points. Thanks.